Alright, my dear children of class 12 science, let's continue solving the new MCQ numerical question from alternating current. Okay, so in the last YouTube video we had solved up to question number 4. Now we solve question number 5. Okay, the question number 5 says that what is the value of inductance? Inductance means L, for which the current is maximum in a series LCR circuit. Now in LCR circuit, current become maximum, means impedance become minimum. And children, you have learned that in LCR circuit, current become maximum, impedance become minimum when two reactants are equal to each other. Two reactants means inductive reactants and capacitive reactants are equal to each other. With capacitance value is 10 microfarad and omega is given how much? Angular frequency is 1000 radian per second. Now to choose the correct option, so let's do the solution of this question. Now question only say that in LCR circuit, the current become maximum. But children, you know current become maximum when XL equals to XC. Now XL means inductive reactance, XC means capacitive reactance. Okay. Now XL means omega L. XC means 1 by omega C. Okay. So let me make L as the subject. So L equals to 1 by omega into omega. This omega will go in the denominator. It will be omega square and there is already C. Now let's substitute the value. 1 by. Now omega means 1000 children, but I write in exponent 10 to the power 3. Okay, with whole square. C means capacitance, that is 10 microfarad. I write directly in microfarad, that is 10 into 10 minus 6. So this is the capacitance. Okay, so let's simplify. 1 by 10 to the power 3 square means 10 to the power 6. 10 into 10 minus 6. Okay, so this is 1 by. Now 10 into 10 to the power 6 minus 6 means 10 to the power 0, which means 1 by 10 only, because 10 to the power 0 means 1. Okay, so 1 by 10 means how much? 0.1 Henry. But in the question, you don't have option of 0.1 Henry. Okay, so but your option is given in millihenry. So we can convert this in millihenry also. Okay, so I will be doing this way, like 1 by 10 Henry. So let me just write 0.1 Henry. So let me just do write this way also. 1 by 10. The 10 to the power 3 I multiply and 10 to the power 3 I'll divide. Okay. And this is, if I just do multiply by 10 to the power 3 and 10 to the power divide by 10 to the power 3, then this 10 and 10 to the power 3 1 cancel out. This is 10 to the power 2 means 100. 10 to the power 2 means what? 100 into, now 10 to the power 3 if I take in the numerator, it is 10 to the power minus 3 Henry. Now 10 to the power 3 minus 3 Henry means millihenry, 1 millihenry. So 1 millihenry into 100 means 100 millihenry. So your option is there in the question paper. Okay, in the question, that is how much millihenry? 100 millihenry. So the correct option is option number what? A. So children, the option is A, that is 100 millihenry. Okay, this is question number 5. Now we go to next question, question number 6 also. Question number 6 says that in an AC circuit, an alternating voltage B equals to 200 square root of 2 sin 100 T is given. Volt is connected to a capacitor of capacitance 1 microfarad. Now RMS value of the current in the circuit is, now we have to find the RMS value of the current. Now there are 4 options. One is 10 milliampere. Next option is 100 milliampere, 200 milliampere, and last one is 20 milliampere. So in order to choose the correct option, even we can do the solution of this question. Now question number 6 solution is simply done in this manner. Now in this question, your voltage is given. Your voltage B equals to 200 root 2 sin 100 T is given. The capacitance value is 1 microfarad. Now when equation like voltage equation is given, then we can compare this equation with the standard equation. So we just write down comparing with the standard equation of this is B equals to B naught sin omega T. Okay, this is the standard equation. So if I compare, then this B naught is equivalent to 200 root 2. And you know what is B naught out here? This is peak value of voltage. So this is 200 root 2 volt. Sin T means this omega equals to 100. So omega means angular frequency, which is 100 radian per second. Now capacitance value is also given, that is how much, 1 microfarad, but we can convert into farad. So 1 into 10 minus 6 farad, because micro means what is the order, 10 minus 6. Now what we need to calculate, the RMS current. Now to calculate RMS current, first of all you have to find RMS voltage, and the formula of RMS voltage is Vrms equals to B naught by root 2. Children, look at this formula. When peak value of voltage known, RMS voltage equals to B naught by root 2. Okay. Now peak value of voltage how much? 200 root 2. Okay. 200 root 2 divided by what? Root 2. So it means root 2 cancel out. Means 200 volt. So we got RMS voltage. Now after calculating RMS voltage, we need to calculate RMS current. But in the question paper, it says that this is for which circuit? The voltage is connected to a capacitor circuit. Only capacitor circuit. That means if you connect certain voltage, this much voltage, to a circuit called capacitance only, then the RMS current is always measured by RMS voltage by a factor that is called capacitive reactance. So let me just write it down. RMS current equals to RMS voltage by XC. Look at the formula. When you connect certain voltage, apply certain voltage to capacitor circuit only, RMS current equals to RMS voltage by this XC is called capacitive reactance. So we don't know XC. So let's first calculate capacitive reactance. Now capacitive reactance formula, children, is 1 by omega C. Remember this. XC equals to 1 by omega C. So let's substitute the value. 1 by omega means 100. Capacitance is 10 to the power minus 6. Okay. So 1 by, this is 10 to the power minus 4. Because 100 means 10 to the power 2. 2 minus 6 is minus 4. Means I take this in the numerator, 10 to the power 4, and the unit is ohm. So capacitive reactance is measured by ohm. Now we calculate RMS current. So what is RMS current? RMS current equals to RMS voltage by capacitive reactance. Okay. So RMS voltage is how much? That we have already calculated, 200 by capacitive reactance is 10 to the power 4. Okay. Now let me take this power 4 in the numerator. Now 200 I can write as 2 into 10 to the power 2. The 10 to the power 4, if I take in the numerator, is minus 4. Means 2 into 10 to the power minus 2. 2 minus 4 is minus 2. This is ampere. This is in what? Ampere. But I can write the answer in what? As the correct option, because your option, if you see, are all given in milliampere. All given what? Ampere? Milliampere. So to write this option in milliampere, what I do? Look at it. I write 20 into 10 to the power minus what? 3. Because in the expression I just added 0, and if I add 0, then you have to add minus 3 or by minus 10 also. Okay. Okay, let me just do this way, otherwise you will not understand. I write on 20. Okay, I write on 2 into 10 to the power 10 by 10 into 10 minus 2. See, I just multiply and divide by 10 because I need to make this power as minus 3, because milliampere means 10 to the power minus 3, which means 20 into 10 to the power minus 2. Now 10, if I take in the numerator, is minus 10, so it will be minus 3. Okay, let me write directly minus 3, because there is power is 1. 1 minus 1, 10 to the power 1, if I take in the numerator, is minus 1. So minus 1 minus 2 is minus 3. Means 10 to the minus 3 ampere means milliampere. So this is milliampere. So because this 10 to the minus 3 ampere means milliampere, so it is 20 milliampere. So the correct option is 20 milliampere. So children, which is the correct option in the expression? Option number D, 20 milliampere. Okay. Now we go to the next question, question number 7. Now this is also a question based on LCR circuit, because LCR circuit is one of the important circuit. And this is question number 7. And question number 7 says that in a LCR series circuit, the potential difference between the terminal of the inductance, that is 60 volt, inductance is 60 volt, between the terminal of capacitance is 30 volt, and across the resistor is 40 volt. Then the supply voltage will be equals to, so 4 options are given. One is 5 volt, 50 volt, B is 70 volt, C is 130 volt, and lastly D is 10 volt. So in order to choose the correct option also, we do the calculation. So children, I have already drawn the circuit diagram of LCR circuit just to make you understand, so that you can solve easily. Okay. This is question number 7, and question says that in an LCR circuit, the potential difference between the terminal of inductance, this is inductance, or in which the potential difference I consider as BL, and this potential difference BL is given how much? 60 volt. This is 60 volt. Then similarly, potential difference across the terminal of capacitor is 30 volt, means BC, I have considered BC, that is 30 volt. And lastly, across the inductor means across the resistor having resistance R, that is BR. I have assumed BR, but how much voltage is given in the question? 40 volt. 40 volt. Okay. So what we need to calculate now? Calculate the supply voltage. Now supply voltage is B to this LCR circuit. So how to calculate supply voltage? So there is a direct formula for this. Okay. And the formula is the supply voltage B equals to square root of BR square plus BL minus BC square. So remember this formula. This B equals to square root of BR square plus BL minus BC square. So let's substitute the value and calculate. Square root of BR means how much? 40 with whole square. BL means 60 minus BC means how much? 30 with whole square. So square root of 40 square is 1600. Now 60 minus 30 is 30. 30 square means 900. Now 1600 plus 900 if we add is square root of 2500. So and unit square root of 2500 is 50, because 2500 is a perfect square of 50. So sorry, the unit is volt, sorry. So the supply voltage is how much? 50 volt. So children, you can see the correct option, which is 50 volt, and that is option number A. So the correct option is 50 volt. Okay, option A. Now we go to the next problem also again, that is question number 8. Question number 8 says that this is the question based on transformer. Now in a transformer, 220 volt is converted into 2020 volt or 200 volt, sorry. 2000 how much? 200 volt. Okay. Now the number of turns in primary coil is 600. Then calculate the number of turns in the secondary coil. So you have to choose the number of current, calculate the number of turns in the secondary coil with 4 options which are given. One is 60, another 600, 6000 and 100. Now the solution of the question number 8 is for a transformer. We are dealing with transformer. The voltage 220 volt which is given is a voltage across primary coil, because input is always across primary. That means the voltage which is supplying in the transformer is 220 volt, that is voltage across primary coil. Then it is converted into 2200 volt, that is the voltage that we obtain always on the secondary coil, that is 2200 volt. Okay. Now in the question, the number of turns in the primary coil is given, means number of turns primary coil means NP, that is 600. So what we need to calculate? We have to calculate number of turns in the secondary coil. So in order to calculate number of turns in the secondary coil, so we use the formula, and the formula is BS by BP equals to NS by what? NP. Okay. So let's substitute the value. BS is how much? 2200 divided by BP means 2220, sorry. NS that we need to calculate, and NP means 600. 0 cancel out. Okay. Yes, we can divide 22 1s are 22, 22 10s are how much? 220. Now let me just cross multiply. So NS equals to 600 into 10 means simply how much? 6000. So how many number of turns in the second coil? 6000. So children, the correct option of question number 8 now you can see is 6000, which is option number C. So option number C is the correct option. Now there are other questions to be discussed. Okay, so that you learn in the next YouTube video.